Ladies and gentlemen of geometry, we're talking about a very specific case about what can happen between a circle and a line. This is called tangents. You might remember a little bit about tangents. This is different than trigonometry with the tangent function. So just kind of pay attention. This is kind of something specific to circles and lines. So a couple things first. Tangent. Tangent literally means touches a circle at one point. All right, touches a circle at one point, and the point where that crosses is called the point of tangency. So line AB touches circle C one time, and it touches at the point of tangency. All right, so that is the line that you're talking about. All right, a common tangent is kind of an example here. So you see that you have one line, but it's tangent to two circles. So for this line L, it touches once here, once here. For this line L here, it touches both. That is a common tangent. So use a straight edge to draw the common tangents. If not, the common tangents do not exist, write NA. So there's a 1 here. All right, so this first one, there's about 1 you can draw right here. All right, that would be 1, or you could draw one right here. You can't draw one through the middle because that would go through more than once. So that would be one possibility to draw a common tangent. Here, you can go in between, like so, or you can go back up through here, like so. All right, those would be common tangents. Here, there's only one, and it would have to go right here. That's the only way it can be a common tangent. All right, so take a second, use a straight edge, whatever you need to use, draw a couple of those. So here's the theorem. In a plane, a line is tangent if and only if it is perpendicular to a radius drawn to the point of tangency. So it's a fancy way of saying this. If a line is tangent, it's perpendicular to the radius. If a line is tangent, it's perpendicular to the radius. And flip that around, if a radius is perpendicular, that line is tangent. That's how that works. Forwards and backwards. So if I look, is KL tangent to circle J? Well, if KL is tangent to circle J, that would mean this is a right angle. And if this is a right angle, that means this is a right triangle. And I can use Pythagorean theorem to test. So does 8 squared plus 15 squared equal 9 squared? Absolutely not. I can tell that right away because 15 squared is already bigger than 9 squared. So I'm going to say no. Take a look here. 6, 8, and 12. Do I have that? Is that going to be tangent? Well, if that's tangent, then that's got to be a right angle. If this is 6, this is 8, this is 12. 6 squared plus 8 squared. Does that equal 12 squared? Well, 36, 64, 144. That's going to be 100. That does not equal 144. So no, it's not tangent. So figure out the value of x. Assume that the segments that appear to be tangent are tangent. So here we're already given, yeah, this thing is tangent. All right, so what I want to do is this. This is a right triangle now. Pythagorean theorem coming back to haunt you. Okay, so that's going to be x squared plus 12 squared. But now here's where you got to be careful. Way too many kids will say that it's equal to 8 squared and then try and figure out later why it doesn't work. This isn't 8. This length right here is not just 8. This is going to be x plus 8. So that's x plus 8 squared. Okay, so now solving becomes a little bit trickier. All right, so x squared plus 144. Now, here's what half you guys are going to do, and the people that are just watching this but not listening to it are going to do this for sure. They're going to write 8 squared plus, or x squared plus 8 squared, which is 64. Then they're going to get 144 equals 64, and then they're not going to realize what, they're going to say that there's no solution. So, if you're smarter than that, you'll realize that this is x plus 8 times x plus 8, and this is going to be x squared plus 16x plus 64. that is going to be the correct thing to do. Okay, so now all of a sudden this becomes not too bad. Subtract x squared, subtract x squared. That goes away. Hey, that goes away too. 144 equals 16x plus 64 minus 64 minus 64. 16x equals 80. So I get x to be 5. That is going to be the common thing. So if you're looking at your neighbor and they say, oh, there's no solution to this one, here you can say, nope, you're wrong. You got to go watch the video. For this one, it's a little bit simpler. X squared plus 14 squared equals 17 squared. So that's going to be 196. 17 squared, I think, is 289. Yep, 289 minus 196. So that's going to be x squared is 93. And that's not a perfect square, so you can leave it as square root of 93. Or give me a decimal. Either way, that's fine. So if two segments from the same exterior point are tangent to the circle, they are congruent. So pretty simple. This is tangent here. This is tangent here. Meet at the same point. Those two are equal. And guess what? They are both still perpendicular. So real simple. They're both tangent. So x plus 15 equals 2x minus 5. This one should take you about 10 seconds to solve that one. Same thing here. 3x plus 8 equals 26 for number 6. So subtract 8, subtract 8. 3x is going to be equal to 18, so x will be equal to 6. So that one's pretty straightforward, I hope. So inscribed, circumscribed polygons and polygons that are not circumscribed. Circumscribed, if you'll kindly look, the big difference is that there is a circle touching all sides of the polygon, but it's still completely contained in the polygon. Okay? Polygon's not circumscribed. Well, this one, the first one, not contained. Second one doesn't touch all sides. And this one, well, doesn't touch any side. So it's got to touch all sides and be wholly contained inside the polygon. So quadrilateral RSTU is circumscribed about circle J. If the perimeter is 18 units, find X. Okay, so perimeter. So that means every single one of these is tangent to the circle. So if they're both tangent to the circle, that means these two are congruent, these two are congruent, these two are congruent, these two are congruent. So 3, 3, 3, 3, X, 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 X. So I've got 1, 2, 3, 4X plus 3, 6, 9, 12 equals 18. So 4x equals 18 minus 12, which is 6. So x should be 1.5. But that's the important piece of this. These are all tangent, so they're all congruent. It's just building on that previous theorem. Okay, that's all I've got. That's kind of the big idea. Make sure you recognize that. Come talk to me with questions, please. Thank you.